Hey everyone, the project I would like to submit for the QPoland Hackathon is the Quantum for Finance. So before talking about it, I would like to introduce myself. So I'm Ao Heng, and you can also call me Chong Wei Sing, and I'm one of the quantum computing enthusiasts, and I have bachelor and master degree at the moment. So the libraries that I use in my project are the Pandas, NumPy, Panilei, and Scikit-learn. The Panda is for handling and analyzing data efficiently. Number is for fast numerical array computations. Panilei is to build quantum machine learning model. And Panilei number is for quantum compatible mathematical operations. Mimma scalar, Scikit-learn Mimma scalar is to normalize features for better training. And now we use the mean square error and R square score to evaluate model performance as a metric, Scikit-learn metric. First of all, we load the CSV data. We load the training data set from HTrain of CSV, which includes the close price column. And now we load the testing data set from HTest of CSV to make future predictions. And now we prepare the data by selecting open, high, low, and volume as input features. And now we remove any training row where the close value is missing. And we set the X as a feature data for prediction and set Y as a target variable for the close price. And we normalize features and targets by creating a member scalar to normalize scale for the feature values and target values. And now we normalize the feature data X to a 0 to 1 range. And now we scale the target value Y and flatten them for model use. And now we load the CSV data for the quantum device. And we set the number of qubits equal to the number of input features. Then we create the quantum device using the for qubit with that many wires. And now we define variational circuit, which means I build a variational circuit that encodes data, applies entanglement, and outputs a measurable value for learning. And now I define the quantum regression model, train the model, and evaluate it. And we got some values for MSE and R-squared score. And now we predict the missing close value in the test data set. And now we save the results as a prediction.csv file. So for the final tips and takeaways, I got MSE mean square error 36,305.7 on average. The model's prediction differ from actual values by decimal square. Lower values are better, so smaller MSE makes more accurate predictions. So therefore, the R-squared score, it is about approximately 67%, 0.686, so it is 67%. This tells us how well the model explains the variation in the data. So that means 67% of the changes in the targets are close price are captured by the model, while the 33% remaining is unexplained. So in short, this model is reasonably good, but there's still room for improvement. So that's it for my presentation. I hope you enjoyed it. And if you would like to see my project source code, you can also check my GitHub link right here. I also would like to connect you with on the link on my LinkedIn account. So thank you for your time, and I would like to see you again. Bye bye.